this something called counterfactual terminology, which is a really useful way to think about things when we talk about state channels. So the definition I just put on screen here. For an on-chain operation X, we use the term counterfactual X to talk about the case where X could happen on-chain. Any participant can unilaterally make X happen on-chain, and participants can act as though X has happened. So these are three kind of three points, and I'll go through an example for when this term is useful. So early on, I talked about payment channels, and we looked at a case where many payments have been done, and this is the final state. So in this case, we can say if we let X be 15 Ether goes to Bob's account and 5 Ether goes to Alice's account, we can say that counterfactual X holds, which means that let's go through what that means. What's the first one? Yeah, so basically this means that Bob and Alice can both act as though Bob can act as though he actually has 5 ETH, and Alice can act as though Bob can act as though he actually has 15 ETH, and Alice can act as though she actually has 5 ETH because of how the payment channel works, and because we went through the proof that if there's ever a disagreement, Bob can actually take control of the 15 ETH. So the reason I introduced this terminology is because when I went through the example of how we do counterfactual instantiation, the X here is Alice and Bob are bound by the terms of the contract. So the next part of my talk, I'll move on into a bit of the details of the specific constructions that we chose to use. So I went through some of the tools that enable us to build really powerful state channels, and I'll go through now how we actually build those channels. So the first thing we introduce is a concept of something called counterfactual state. So a smart contract contains counterfactual state when every person in the channel can unilaterally update the on-chain state to the given counterfactual state. So this is kind of the off-chain analog of storage. So we think of an Ethereum contract as, when it's deployed on-chain, it has state because it has state in the form of its storage. So people can modify the storage, and this one is kind of the off-chain version of this. And the counterfactual object is just a counterfactually instantiated contract that contains counterfactual state. So this is a bit of a mouthful, but this is actually the complete definition. And I'll give you an example of how this makes sense in state channels. So this is a diagram showing an example of a dispute within a channel in the style that we're building. So there's a payment channel counterfactual object, and in this dispute, the payment channel counterfactual object has actually been deployed to chain. So what the multisig does is that it does a call, like a message call in Ethereum, to read the state of this thing, and then after that it sends 3 ETH to Alice and 2 ETH to Bob based on the state of this contract. So in this diagram, the payment object has actually been deployed because there was a dispute. But during normal operation, it's a counterfactually instantiated object, which means that it doesn't actually exist on chain. So this means that our state channels consist of basically for every state channel we have a multi-state, and that's it. Everything else is counterfactually instantiated. It's not off-chain. When there's a dispute, only then do you put actual code on-chain. Some other details about how we organize this is we have a kind of dependency relation between counterfactual objects. So this diagram shows that the payment channel object, this one only finalizes if this other object has a certain state. So by updating the state of this object no longer finalizes. So we have deleted this object. And arranging things in this structure allows us to do things like atomic state transitions within a channel. So if you have a channel, for example, that has, we have a channel that currently has only a payment channel, and then what we can do is we can set up two other counterfactual objects, a payment channel with a smaller balance, and a corporate counterfactual object where the winner gets to leave. So we set this dependency structure, so these two things actually, they're kind of not real now, right? Because if we deploy the entire thing on-chain, we can deploy this, but when we try to deploy this and when we try to make use of it, this object looks at the nonce and says that this number is not high enough, so it refuses to exist. And then we change it to 4, and then we topically transition into this new state. So this is the diagram we start off in the beginning of my presentation, and kind of like it shows all the objects in a typical state channel. So like I mentioned before, the only thing that exists on chain is a multi-signature wallet, and then we have this nonce where like everything depends on it, and this allows us to kind of make atomic state transitions to other things. And these are like payment channel objects that observe other things. So this one says, for example, whoever wins this chess game gets 5 ETH or something.